Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel, and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Welcome to this comprehensive tutorial on Apache OpenJPA. OpenJPA is a robust Java persistence framework that implements the Java Persistence API specification. It allows developers to map Java objects to relational databases with ease, offering features like lazy loading, caching, and transaction management. Whether you're building enterprise applications or optimizing data access layers, OpenJPA provides the tools you need to manage persistence efficiently. So why choose Apache OpenJPA over other persistence frameworks? First, OpenJPA is optimized for performance, featuring built-in caching and lazy loading to reduce database overhead. It also supports flexible configuration options, allowing developers to define entities using either annotations or XML. These features make it particularly well-suited for enterprise-scale applications where performance and scalability are critical. Before diving into implementation, let's cover the core concepts of OpenJPA. The Entity Manager is responsible for managing the lifecycle of entity instances. A persistence unit acts as a configuration container, typically defined in a persistence XML file. Entity classes represent database tables, and annotations are used to define mappings and behaviors such as primary keys, relationships, and constraints. Setting up OpenJPA involves a few key steps. First, add the OpenJPA dependency to your project using Maven or Gradle. Next, configure the persistence XML file with your database connection details. Define your entity classes using JPA annotations, and finally, initialize the Entity Manager factory at application startup. This factory will be used to create Entity Manager instances for database operations. Entity mapping is a crucial part of OpenJPA. Use the @entity annotation to mark a class as a persistent entity. The @id annotation defines the primary key, while @column maps fields to database columns. Relationships between entities are defined using annotations like @many-to-one and @one-to-many. These annotations provide a clean and intuitive way to map Java objects to relational database structures. The persistence context is a key concept in OpenJPA. It manages the state of entities, tracking changes and synchronizing them with the database. Entities can exist in different states, managed, detached, or removed. OpenJPA supports both transactional and extended persistence contexts, giving developers flexibility in how they manage entity lifecycles. The Entity Manager provides several key operations for managing entities. The persist method adds a new entity to the persistence context. Merge updates a detached entity, remove deletes an entity from the database, and find retrieves an entity by its primary key. These operations form the backbone of CRUD functionality in OpenJPA. Lazy loading and eager fetching are essential for optimizing performance in OpenJPA. Lazy loading defers the retrieval of related data until it's explicitly accessed, while eager fetching loads related data immediately. These behaviors can be configured using fetch attributes in annotations, allowing developers to fine-tune performance by reducing unnecessary database queries. Caching is a powerful feature in OpenJPA that can significantly improve performance. The L1 cache operates at the Entity Manager level, storing entities for the duration of a transaction. The L2 cache is shared across Entity Manager instances and can be configured with various eviction policies. Properly configured caching reduces database load and accelerates query responses. Transaction management is critical for maintaining data consistency in enterprise applications. OpenJPA supports both JTA and resource-local transactions, offering flexibility in deployment environments. Transactions can be automatically demarcated using annotations or programmatically controlled via the Entity Transaction API. This ensures that data operations are executed reliably and consistently. OpenJPA supports querying using JPQL, an object-oriented query language that closely resembles SQL. JPQL allows you to perform select, update, and delete operations on entities. You can filter, sort, and aggregate data using familiar SQL-like syntax. Because JPQL operates on entity models rather than tables, queries are type-safe and database-independent. While JPQL is powerful, there are times when you need the full flexibility of native SQL. OpenJPA allows you to execute raw SQL queries, mapping results to entities or scalar values. This is particularly useful for complex database operations or when leveraging database-specific features. Native SQL provides the flexibility needed for advanced use cases that go beyond standard JPA capabilities. Concurrency control is essential in multi-user applications. OpenJPA supports both optimistic and pessimistic locking strategies. Optimistic locking uses version attributes to detect conflicts, while pessimistic locking acquires database locks to prevent concurrent modifications. These mechanisms ensure data integrity in high concurrency environments and can be configured using version annotations and lock modes. Performance tuning is crucial for applications handling large data sets. OpenJPA offers batch fetching to reduce N+1 query problems, configurable batch sizes for optimal performance, and support for bulk operations. Additionally, integrating connection pooling can significantly improve throughput. These features make OpenJPA a strong choice for high-performance enterprise applications. Detached objects are entities that exist outside the persistence context, often used in web applications with session management. The merge operation synchronizes the state of a detached object with the persistence context. While powerful, detached objects require careful handling to avoid inconsistencies, especially in distributed environments. Understanding OpenJPA's architecture helps in leveraging its full potential. The core modules include the broker, which coordinates operations, the store, which handles database interactions, and metadata, which processes entity definitions. OpenJPA integrates seamlessly with JPA annotations and XML configurations, supports multiple database vendors, and is extensible through plugins and callbacks. OpenJPA provides lifecycle callbacks and listeners to enhance control over entity behavior. Annotations like @pre-persist and @post-update allow you to execute custom logic at specific points in the entity lifecycle. You can also define custom listeners for more complex business logic integration. These features are invaluable for tasks like validation, auditing, and data transformation. OpenJPA simplifies database schema management through automatic generation and validation. It can generate database schemas directly from entity definitions, validate against existing schemas, and support incremental updates. This reduces the manual effort required for database management and ensures consistency between your object model and database structure. OpenJPA integrates seamlessly with the Spring framework, especially Spring Boot. It supports declarative transaction management, allows auto-wiring of EntityManager factory and repositories, and simplifies configuration and testing. This integration makes it easier to build robust, testable applications with minimal boilerplate code. Let's look at a real-world use case, an e-commerce platform. OpenJPA can efficiently manage product catalogs and inventory, handle customer orders and transactions, optimize query performance through caching, and ensure data consistency using locking mechanisms. These capabilities make it an excellent choice for complex, data-driven applications. When comparing OpenJPA with Hibernate, both are robust JPA implementations. OpenJPA excels in caching and lazy loading performance, while Hibernate benefits from broader community support and tooling. Both support JPA standards and annotations, so the choice often depends on specific project requirements and existing technology stack preferences. OpenJPA offers advanced features like fetch plans and projections to optimize data retrieval. Fetch plans allow you to control which related data is loaded, while projections enable selective field loading. These features reduce memory footprint and network overhead, leading to improved application responsiveness and better user experience. Security is paramount in enterprise applications. OpenJPA helps prevent SQL injection through parameterized queries, supports access control via entity-level permissions, and integrates with data encryption mechanisms for sensitive information. Additionally, it can be configured to maintain audit trails, meeting compliance requirements for data governance. Migrating from other ORMs to OpenJPA requires careful planning. Strategies include gradual migration for existing projects, leveraging compatibility with JPA annotations and APIs, using tooling for schema and data migration, and conducting performance benchmarking during the transition. Proper planning ensures a smooth migration with minimal disruption. Effective testing is crucial for reliable applications. With OpenJPA, you can use in-memory databases for unit testing, mock EntityManager for isolated tests, perform integration testing with real databases, and conduct performance testing for query optimization. These strategies ensure your persistence layer is robust and performant. Monitoring and debugging are essential for maintaining high-performance applications. OpenJPA provides built-in logging for query and transaction tracing, exposes performance metrics through JMX integration, supports query plan analysis for optimization, and offers connection pool monitoring and tuning capabilities. These tools help maintain application health and performance. To get the most out of OpenJPA, follow these best practices. Use lazy loading judiciously to avoid N+1 issues. Configure caching appropriately for your use case. Validate entities and handle exceptions gracefully, and regularly profile and optimize queries. These practices ensure your application remains performant and maintainable. The OpenJPA community offers a wealth of resources for learning and troubleshooting. Start with the official Apache OpenJPA documentation, engage with community forums and mailing lists, explore third-party tutorials and blog posts, and check out GitHub repositories with sample projects. These resources are invaluable for both beginners and experienced developers. While OpenJPA may not be as actively developed as some other frameworks, it continues to receive maintenance and bug fixes. The project maintains compatibility with newer Java versions, integrates with modern cloud platforms, and benefits from community-driven feature enhancements. Its stability and performance make it a reliable choice for enterprise applications. Even experienced developers can fall into common pitfalls with OpenJPA. These include the N+1 query problem from improper lazy loading, transaction management mistakes, incorrect caching configurations, and ignoring connection pool settings. Awareness and proper configuration can help you avoid these issues and build more robust applications. Deploying OpenJPA in enterprise environments requires careful consideration of clustering and load balancing strategies, database connection pooling optimization, security configurations for production, and monitoring and alerting for production systems. These factors are critical for ensuring scalability, security, and reliability in large-scale deployments. In microservices architectures, OpenJPA can be integrated as a stateless persistence layer. Key considerations include distributed transaction handling, service mesh integration for resilience, and adopting an API-first approach with REST-TFL services. These practices ensure that your persistence layer scales effectively in a distributed environment. For cloud-native deployments, consider containerization with Docker and Kubernetes, auto-scaling and resource management strategies, cloud database integration and migration, and observability through comprehensive logging and metrics. These practices ensure that your OpenJPA-based applications are optimized for modern cloud environments. Performance tuning is a deep topic in OpenJPA. Techniques include query optimization with proper indexing, caching strategies with effective eviction policies, connection pool sizing and configuration, and JVM tuning for persistence workloads. Mastering these areas can lead to significant performance improvements in your applications. When issues arise, knowing how to troubleshoot is essential. Common problems include diagnosing and resolving connection leaks, handling lazy initialization exceptions, debugging transaction rollback scenarios, and resolving entity version conflicts. Having a systematic approach to these issues can save significant development time. To summarize, Apache OpenJPA is a powerful JPA implementation ideal for enterprise applications. Its key features include advanced caching, lazy loading, and robust transaction management. Proper configuration and tuning are crucial for achieving optimal performance, and its integration with Spring and cloud platforms is seamless. Mastering these aspects will help you build scalable, high-performance applications. Thanks for watching this deep dive into Apache OpenJPA. If you found this tutorial helpful, please give it a like and subscribe for more Java and persistence tutorials. Don't forget to comment below with your questions or experiences with OpenJPA. Check out the description for related resources and links to sample projects. See you in the next video. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.